Hello, so we are on a new topic. So this is Module 2, Topic 2, and as you can see right over here, this is System of Linear Equations. This might be the first time that we've seen a system, but we're going to go through the first learning goals on page 307. And this lesson is going to cover from 307 to just about 311. The first learning goal, write a system of equations to represent a problem situation. And the second one, analyze and solve a system of simultaneous linear equations graphically. So we'll graph it. We're just going to do one problem on the review. Let's do number one. Okay, we have the equation y equal to 2x plus 5, and the direction tells us determine an ordered pair x and y that represents a solution to each equation. And to remind yourself, right, for a solution is just a number or a set of numbers that make the equation true or satisfies the equation. I'm going to give you an ordered pair of, let's say, say 1 comma 7. I just made this up, but 1 represents the x value, y represents the, or 7 represents the y value. If I were to rewrite this equation and plug in 1 in for x, I'll put that in parentheses, and 7 in for y, and if we simplify this using order of operations, we would get a true statement. So we would multiply first, right? 2 times 1 is 2, and 2 plus 5 is 7. And we had 7 on the left side as well. So this is a true statement, right? 7 equal to 7. There's an infinite number of combinations of ordered pairs for x and y that would make this equation true, but this is what a solution means. Okay. All right. We're going to skip 308, getting started. We're going to go right into activity 1, and this video will be focusing only on activity 1. The context we'll be looking at, if we're familiar from other lessons that we've done working with buying and selling shirts. So it says the PTO, the parent teacher organization, is trying to raise funds, and it says they sell shirts for $8 each. Let's underline that. And it costs $4. I'm going to highlight this in red, to make each, plus a $160 setup fee. Okay, so there's two things here, right? One, we're going to be selling, and a certain amount of money where we're purchasing these shirts to then sell. Okay, so number one, it says write an equation that represents the organization's cost in dollars to buy the long sleeve t-shirts. Okay, so for this, when normally we write an equation, we have to figure out what form we're writing it in. This will be writing it in slope-intercept form, y equal to mx plus b. and since this is we're buying the shirts, that's what I highlighted in red in our initial context. Where we begin here is going to be the 160, that's the setup fee. And it's how much we move, our m value is $4 each shirt. So this is the equation y equal to 4x plus 160, right? Where we have, this is per shirt in order to buy, and this is where I'll just put where we begin. So we go to the store, in order for them to design the shirt, it's $160, and then we have to purchase $4 for every shirt that we want to purchase. Okay, and then number two, write an equation that represents the organization's income. So we're trying to raise some funds, right? This is a fundraiser. So we're selling it for $8 a shirt. There's no initial value. There's nothing where we begin with in terms of selling. So this is just y equal to 8x, right? If I purchase one shirt, or we sell one shirt, right? 8 times 1, 8. If I sell 2 shirts, 8 times 2, 16. So we're just multiplying whatever x is by 8 for a number of shirts. Okay. We're going to use that information to help us for these varying things that we have here. But just like we did in math here, we do have to write an expression. So the cost. Actually, before we get to this, we have an expression let's say these t-shirts are going to be represented by X. The cost is 4X plus 160. And then dollars, right, or for income is just 8X. So we're just going to do a couple and hopefully see a pattern here. Okay. Right, if I plug in 0 into X, 4 times 0 is 0, and 0 plus 100 is 60, is just 160. So it's going to cost $160 to purchase no shirts. For 10 shirts, right, we'll plug that in for X. 4 times X, or 4 times 10, is 40. And 40 plus 160 is 200. If we plug a 20 in there, 8 times 20 is, 4 times 20 is 80. 80 plus 160 is 240. And this doesn't increase by a constant amount, but I'll give you the remaining values here. So this is 300, 360, and 560, right? If we went by equal increments for X, then we would have equal increments for the cost per shirt. Anyways, now moving on to income, right? We're still plugging in all of these values, but we're plugging them into X here. So it means we're just going to multiply by 8. So 0. 0 times 8 is 0. So if we sell no shirts, we raise no money, right? If we sell 10 shirts, we'll get $80, right? 8 times 10. 20 times 10, 160. And I'll give you the rest. 280, 400. The last one, if we sell 100 shirts, 100 times 8, 800. Okay. Now, for us to figure out our profit, right? Profit is how much we're buying minus how much we're selling. So how much money are we actually raising here? Okay. So what you have to do from here to here is you just have to subtract. So what this is here, it's represented as, right, 8X minus the cost, which is 4X plus 160. So really what this is, it's the income that we make minus the cost. Okay, so so we're actually going the other way. Sorry about that. I drew the arrow the opposite way. Okay, so we're going to take 0 minus 160. So what this is saying is if we don't sell any shirts, we're out $160, right? So we're in debt. Let's go to the other one, 80 minus 200, that is negative 120. So we're going toward getting out of debt. Next one, 160 minus 240, that is negative 80. And I'll just give you the rest. This is negative 20. And then now we have positive. We're making $40 in profit. And this last one for 100 shirts is $240. So $240 in profit that we can then spend for whatever the PTO is trying to organize. Okay, we're going to take that information, we're going to graph it. So when we graph this, you're going to be using, right, X is number of t-shirts, and then Y is money in dollars. So we're probably going to be looking at one of these two options here for cost and income. So number 4. Create graphs to represent the cost and the income on the coordinate plane shown. Be sure to label your lines. We're going to have two different lines here. One line is going to represent cost and one line is income. Number 5 says use the graphs to answer each question. Describe your reasoning in terms of the graph. Okay, so we'll get to that soon, but let's go and graph the first one here. All right. So if we're looking at cost, I'm going to be looking right here and here. So this is a coordinate of 0, 160. And then we'll go right 10 and 200. And you can see the rest. I won't write that out, but we'll refer to it. I'm going to let's put cost. I'm going to highlight this in red here. So all of these will be in red. All right, we'll write this out. I'll put cost in red. Okay. So the first one is 0, 160. So 0, 160, that means I don't move at all left and right. I just go up 160, so I'm on the y-axis. This is where we begin. This is our y-intercept. Next one, we already wrote it out, but that is 10, 200. 10, 200. So if I go to 10, which is right here, and 200, which is right here, and I join those, that is right here. And we'll get some type of linear graph here. Okay, next one is 20 and 240. So 20 right here, 240 right here. Okay, see where they join. We're still along this linear path, and we'll probably just do 2 more, or maybe just 1 more. Okay, 35, 300. 35, 300. 300 somewhere right here. Let's go right here. And then the last one that we'll do that we can fit on the graph, we can't do the 100, but we'll do 5 or 50 to all the way up to 360. So 50, which is almost the edge of the graph here, and 360 right here. Let's see where they join. Looks like that. All right, so as best we can, let's go ahead and graph this. If you want, you're welcome to use a straight edge or a ruler. You're welcome to grab that. Right next to this, I'm just going to put that this is the cost, and this was the equation, y equal to 4x plus 160. Okay, now I'm going to go in a different color here for our income. So for our income, right, that is going to be, I'll put this in blue, and we're looking at still the same x value, but I'm looking at the third column. So here and here, right, all of these. And I'll just draw it. Let's just draw this. All right, so you're welcome to pause the video at this point and try to graph it, but I'm going to graph this as we're kind of going on. 0, 0 is the first one. So that's at the origin. 1080. Right there. 20, 160. So right here, 160 looks like there. 35 and 280. 35, 280. So I'm going to connect what I have so far, just so we can kind of see. And it's not quite lining up. Something like that. And then the last, well, let's do 2 more. 35 and 280 we just did. We'll go 50 and 400. So 50, 400. Toward the top right of this entire thing. Somewhere right here. Okay, looks like that's going to be the closest I can get it. All right, so what's in blue? This is income. And income is represented, the equation that we have for that is y equal to 8x. So notice, right, for these two varying things here, I couldn't quite get this correct, but something like this. All right, let's look at this graph to analyze and write out the answers for these varying questions. So for number 5, A, determine the number of long sleeve t-shirts for which the cost is greater than, let's highlight this, I'll put this in a neutral color. The cost is greater than the income. So cost is written in red, income in blue. So if it's greater than, that means it has to be above. So which part is the red line above the blue line? So it's pretty much, I'm going to draw something and then erase it. So from 0 all the way to, I think this right here, whoops. This is where the red is above the green. So this is from 0 shirts all the way to 40 shirts. So just below 40 shirts, that's where the cost is greater than. So let's go and write that in. All right. So for this, the cost is greater than the income when the PTO, the parent-teacher organization, sells fewer than 40 shirts. 40 long sleeve t-shirts, but I'll just say 40 shirts. Okay. So if they don't sell that much, that means that they're going to be in debt, and that's represented here in our profit. Right? See all these negative values above this line here? Right? So we got to sell more than 40 shirts in order to make a profit. We'll talk about that in the next page, but let's go into the other prompts. Determine the number of long sleeve t-shirts for which the income is greater than the cost. So income is blue. Which section of this graph is blue above? Again, this was 40. So everything to the right of this. So if the PTO sells more than 40 shirts, that blue path is higher than the red path, right? Is higher than the cost. So pretty much there, we're just gonna say, right, for B, when the PTO, when the PTO sells more than. More than 40 shirts. All right. And then we kind of answered already C, right? C says determine when the cost is equal to the income. So when are they exactly the same? Now, when you're asking that question, that means when the two lines are overlapping. They're overlapping pretty much at 40 here. So that is, if I go up to this graph, right there, and that is, in terms of money, it's $320. So when is the cost equal to? It's when we sell exactly 40 shirts. And we'll say that both the two things, right? Both the cost and income, both the costs and income are $300 and $320. Okay. All right, so that's what's going to be for us to purchase them, and that's what's going to be as when we sell it as well. It's going to be $320 for each. And then D says verify solution algebraically. Algebraically, this means right, computation with numbers. Right, we're all in pre-algebra. Oh my goodness. Okay, numbers and letters. So with variables. So pretty much we're looking at an equation. Okay. So how do we write this out? So I'm going to write the thing that we have, which is we do have an equation here. Let's write out one of the equations that we had. Y equal to 4x plus 160. Now we had a solution, right? That solution was where they were equal. That was 40 shirts and $320. I'm going to plug this in for x and this for y. Okay, so just like we did in the warm-up. So instead of y equal to, we'll put 320 equal to. Instead of 4x, we'll put 4 times 40. And I'll put this 160 at the end. Okay, order of operations, we'll multiply. So I'm going to rewrite this. Multiply 4 times 4, 40 is, 4 times 4 is 16, add a 0, that's 160, plus 160. You can do this mentally, right? You can do, instead of 160 plus 160, why don't you do this? Let's do 100 plus 100. And then maybe you can add the 60 and 60 afterwards. Okay, right, this is 200, and this is 120. 200 plus 120 is 320. So that's a true statement, right? So we proved it two ways. Right? We proved it graphically that this equals each other at 40, and algebraically by plugging in some values into the equation. Okay, we could have done this to the other equation as well. Actually, let's do that too. The other equation was y equal to 8x. So let's plug in 40 and and then we'll put in 40 for this. Okay, well, maybe I don't know what 8 times 40 is, but 8 times 4 is 32. So I'll put 32 and add a 0 at the end, another place value. That's also a true statement. So it satisfied the other equation as well. Okay. All right, good. So still continuing onto the last page here for activity 1. That's page 311, and then we'll call it from there. A couple of key vocabulary terms. Whoops. Okay. So it says the point of intersection is the point at which the two lines cross on the coordinate plane. So an example here, if I have two lines, that's the point of intersection. I'll draw arrowheads at the end. When one line when one line represents an item's cost and the other line represents the income from selling the item, you call that the intersection point the break-even point, when you go from negative into now positive, or vice versa. So number 6, what is the break-even point for selling and making the long sleeve t-shirts? All right, so we just answered that, but I guess I'll just put it more formally here to answer this question too, now that we have this vocabulary term. The break-even point is 40, 320. What are the costs and income at the break-even point? Right, the cost and income, right, for us to buy the shirts and then the income from selling the shirts are both $320. What is the profit from the t-shirts at the break-even point? So the break-even point is where we go from negative to positive. So what's in between negative to positive? Right, the profit. Right, the number that's in, if you think of a number line, right, from negative to positive, the number that's in between is 0. So the profit is $0 at the break-even point. I should probably put is. All right, and last two parts for number 9. What do the coordinates of the point of intersection mean in terms of the fundraiser? Okay, so the point of intersection, I'll put PT for points of intersection, I'll abbreviate that, 40, 320. So what does that mean in terms of the situation? Means that the PTO buys 40 long sleeve t-shirts. I'll just put shirts. In terms of that, it costs $320. And finally, it sells for also $320. And in this case, as we saw in the graph, right, there is no profit. Right, or the fundraiser breaks even. Okay. All right, and that's what a lot of companies have to do, right? A lot of companies have to use money to make money. If they don't sell or meet their target, then they lose money, right? That happens quite a bit in businesses, and sometimes that's when businesses, right, either go bankrupt or they can no longer be a business. Anyways, let's get to number 10. So state the number of long sleeve t-shirts that PTO must sell to make a positive profit. They need to start making money. So if if 40 t-shirts produces a profit of $0, then the PTO must sell, right, anything above 40. We'll say the PTO must sell at least right? Since it's 40 for it to break even, just one more. 41 t-shirts to make a positive profit, right? We can have a negative profit, a zero profit, that's break even, or in this case, a positive profit where we're now making money in this fundraiser. Okay, all right, we'll call it there. We'll go on to activity 2-3 on the next video.